This is a diagram of a hydrogen atom. Label the proton with a plus sign and the orbital electron with a negative sign. The electrical interaction between the nucleus and the orbital electron is a force of which one? It is a force of attraction, right? Okay? That's what holds an atom together. Because the nucleus is positively charged, okay? And the electron is negatively charged. Overall, they're going to feel a force of attraction towards each other. And that's what holds them together there. Okay? Moving on. According to Coulomb's law, F equals K, Q1, Q2 over the distance squared, where Q is for charge. K is an electrical constant. It's like in math, where you learn that in order to make an equation equal to each other between relationships, you need a constant, okay? That's just all that is. Q is the amount of charge used at distance. If either the charge of the nucleus or the orbital electron were greater, the force between them would also be what? Would also be greater. So you learn that in chemistry, if you have more protons in the nucleus, it'll attract the electrons more tightly, right? So that's why after hydrogen, anybody know what's next on the periodic table? You have, okay, well, oxygen's further down. Okay, that's number 8. Okay, helium is next. That's correct. Okay, helium atom only has one more proton and one more electron. So 2 protons, 2 electrons, and you have to have 2 neutrons. When we look at hydrogen, we only have 1 proton and 1 electron here. When we look at helium, we have 2 protons, 2 neutrons, and 2 electrons. Ironically, a helium atom is actually smaller than a hydrogen atom in terms of its volume, even though it has more mass because it has more particles. It's got 4 particles in the nucleus versus 2, but it's smaller, okay? Because there's more electrical interaction, more charges there. And the nice thing about helium is because it has a full electron shell. You guys remember from chemistry? Does helium blow up in your face like hydrogen? No, it's a noble gas. It's stable, that's why we put it in birthday balloons and not hydrogen gas. Okay? And all of chemistry is really looking at these electrostatic interactions between positively charged nuclei and negatively charged electrons. Those of you that are freaking out now because we're talking about chemistry, don't worry. We're just touching on it and we're moving on. Okay? Anyhow, let's see how you guys did on the rest of the sheet. Okay? If the distance between the nucleus and the electron were greater, what would happen to the force? Okay, yeah, the force is less. And a lot of chemistry and making up new medicines and electronics is getting atoms to bond or not bond based on their electrostatic chemical properties, which is all about how the proton bonds to the electron through electrical attraction. Okay, and electrons repelling each other. How about this? If the distance between the nucleus and electron were doubled, what would happen to the force? It'd become how much? Force would be 1/4 because it's distance squared. Okay? Force depends on the amount of charge directly, okay, Q1, Q2, but then it's inversely related to the distance squared. It's 1 over the distance squared. Okay? Moving on. We're going to look at a couple more scenarios, see if you understand this. Okay? Consider the electric force between a pair of charged particles a certain distance apart. So by Coulomb's law, if the charge on one is doubled, what happens to the force overall? The force will also be what? Will also be doubled. Good. B, if instead the charge on both particles is doubled, now you have twice as much charge on each side, what's going to happen to the force? It's going to be quadrupled, 4 times as much, right? If instead the distance between the particles is cut in half, what's going to happen to the force? It's going to still be quadrupled because what's 2 squared? 4 times as much, okay? What if we cut the distance in half and we double the charge? It's going to be quadrupled and quadrupled, which will be 4 times 4 is 16 times as great. Because if the distance is half, you're going to have 4 times the force, and you double the charge, which is 2 times 2. That's also 4 times as much, so 4 times 4 is 16. Okay? And there we have it. A little practice with